Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about derivatives of our favorite topic, trigonometry. The derivative of sine is cosine. The derivative of cosine is negative sine. So when we talk about these two formulas, they're very basic formulas that you need to remember, and they can help us with everything else we do. If the derivative of sine is cosine, what is the derivative of 3 times sine? Well, we use our constant multiple rule, and we take 3 times the derivative, which would be 3 times cosine of x. Okay? So this next one, remember, this is just 1/2 times cosine of x. So how would I find the derivative of this function, f of x? Well, the derivative would be 1/2 times negative sine of x. So I could say this is negative sine of x over 2. Either one of these would be absolutely fine for this derivative. Okay? Now, if I combine a couple of functions, big deal, we take the derivative of each term. What's the derivative of x squared? Well, it's 2x. What's the derivative of cosine? Well, it's negative sine. So if I'm subtracting cosine, the derivative would be plus sine of x. Pretty easy so far. And let's do one more derivative here. H prime of x. The derivative of sine is cosine. The derivative of cosine would be minus sine of x. So there's our derivatives. And a lot of these just used our power rules, or it used a constant multiple rule. Pretty easy to figure some of these out so far. Now, when we start taking the derivatives of tangent, let's prove tangent. What is another way to write tangent? Well, most people are going to say tangent is sine over cosine. So what we're going to do here is we're going to do a quotient rule. We're going to take the derivative of the top times the bottom minus the top times the derivative of the bottom would be negative sine. So that would make this plus in front of that term. And this is all over the bottom squared. Now, if you look at the top, this is cosine squared x plus sine squared x. And if you guys remember your trig, I do believe that equals 1. And what's 1 over cosine? Well, that's secant. So 1 over cosine squared would be secant squared x. That is the derivative of tangent. The derivative of tangent is secant squared. And I could do a very similar proof to show you that the derivative of cotangent is negative cosecant squared. Okay? Now, let's do the derivative again. Let's prove this time secant. The derivative of secant, what's another way to write secant of x? Well, secant of x is 1 over cosine. So we can do this 2 ways. Let's just use the quotient rule again. We're going to take the derivative of the top times the bottom minus the top times the derivative of the bottom, which would be negative sine of x, all over the bottom squared, which is cosine squared x. So this comes out to be sine of x over cosine squared, which is cosine of x times cosine of x. And take a look at this. The 1 over cosine, there is your secant of x. The sine over cosine is tangent of x. So the derivative of secant is secant times tangent. And we could do a very, very similar proof to show that the derivative of cosecant is negative cosecant of x, cotangent of x. Hey, did you notice when we look at our formulas, anything that has cosine, cotangent, cosecant, they all have a negative derivative. So that might help you remember your derivative functions. Let's practice a few problems right here. And some of these involve more than one rule. This first problem to find f prime of x involves a product rule. The derivative of the first is 2x times the second, which is cosecant of x. The product rule is plus the first function, which is x squared, times the derivative of cosecant. Go back in the video and look. It's negative cosecant of x, cotangent of x. So the derivative here is 2x cosecant of x minus x squared cosecant of x, cotangent of x. There's my derivative for that first problem. The second problem is actually very simple as well. It's just a constant multiple. If you have negative 2 times a function, you take negative 2 times its derivative. The derivative of secant is secant of x, tangent of x. So that is just a constant multiple rule. The previous one was a product rule. This next one is also a product rule. To find h prime, the derivative of the first function would be 6x squared times cotangent of x. Product rule is plus. It would be 2x cubed, and the derivative of cotangent is negative cosecant squared x. So my derivative for h prime is 6x squared cotangent of x minus 2x cubed cosecant squared x. So again, we're using power rules, we did product rules, we did constant multiple rules, and f of x on this last problem actually uses a quotient rule. The quotient rule for f prime of x here would work this way. You take the derivative of the top, which is secant squared of x, times the bottom, which is x, minus the top, which is tangent of x, times the derivative of the bottom, which is just 1, all over the bottom squared. And ladies and gentlemen, there's not much I can do to simplify that. That is our derivative. And this is just a start to what I can do with trig functions and derivatives. We haven't even touched on the chain rule with derivatives, which will pop up in another video. If you like this video, please hit the like button. Feel free to subscribe to my channel. I'll have more videos being made in the near future.